Welcome to physics online session. In this today's class, we'll discuss dual nature of radiation and matter. In this chapter, we are going to discuss the dual nature, nothing but particle and wave nature of radiation and matter. Okay. So first, we have to know what is matter and radiation. You know the definitions of matter. What is a matter and radiation? So first, we have to know what is a matter. So anything which is having some mass and occupying some space, occupying some space, volume, volume, and the space is said to be the matter. Okay. Generally, matter has particle nature. Particle nature. Okay. So example. We can take any example. A bullet. Bullet is when a bullet fired from a gun. So in mechanics, the motion of every body, most of the body is taken as particles. Okay, most of the bodies which are in motion are considered as particles. So first we have to know what are the characteristics of particles. Characteristics of particle. Okay, so we are taking a bullet example. Bullet. So bullet has a mass. Yes, sir. So it has some mass, so it moves with some speed or velocity, so it has some momentum, and it has a kinetic energy, nothing but it has energy associated with it, kinetic energy, particularly kinetic energy when it is in motion. Next, it has a location, very important characteristic property. It has a location. So a bullet is when a bullet is fired from a gun, okay, so we can say the location of the bullet at a particular time. So if you know the speed of the bullet, you can tell the location of the bullet after some time. Okay, so if you know the speed, then you can analyze what will be the location of the bullet after 10 seconds. Okay, these are the characteristic property of the particle. Okay, generally matter has particle nature. Bullet is made of particles. It is made of atoms. It is a matter. It has a particle nature. So, and these are the characteristics of particle. So particle has a mass, a speed, momentum, kinetic energy, and very important characteristic property is location. Particle can be located in the space. Okay, and this is about the matter. Matter generally has particle nature. Please remember, matter has generally particle nature. Next we will discuss what is radiation. Radiation is of different types. It extends from gamma radiation to microwaves. Radiation has so I'll use this only. So radiation has wave nature. Generally, radiation has wave nature. Okay, matter has a particle nature and radiation has a wave nature. Okay. So what is a wave? You know, already we have discussed in the wave chapter. Wave nothing but spreading of disturbance in the medium. Spreading of disturbance in the medium. The medium which carries energy which carries energy, which carries energy and momentum. Okay, and about the wave nature. Radiation has wave nature, and example, light waves. You can take light has a light is a radiation. So example, light waves. Light has a wave nature. uh, and what are the characteristics of wave nature? characteristics characteristics of characteristic properties characteristic properties of wave. Okay, so wave has so wave has no location. It has no location. It cannot be located here and there. It continuously spreads in the medium. It has no location. Okay, very important property. It has no location and it has energy. It's already in the definition. I told that it carries energy and momentum. So it has energy and momentum associated with it, and wave has wavelength. It has wavelength, frequency, and time period, etc. Okay, the wave is specified with these characteristic property. Okay, it has a wavelength, frequency, energy, momentum, but it has no location. Okay, this is about the radiation. Okay, so and we have discussed what is matter and radiation, and what are the two natures, particle and wave nature of particles. In this chapter we are going to discuss the dual nature of radiation and matter. So um, means sometimes radiation has a wave nature, but in this chapter, in the first half of this chapter, we'll discuss, we prove with by some experiments that radiation can also behave like a particle as well as matter. Generally matter has a particle nature, but matter can also behave like a wave. The first half of the chapter will prove the particle nature of radiation. In the second half of the chapter we'll discuss the wave nature of matter. Okay, this is about the dual nature of radiation and matter, and so the first topic from this chapter is photoelectric effect. So okay, so photoelectric effect verifies proves the particle nature of radiation. So before going to discuss the means the part photoelectric effect, we have to discuss some introduction topics. First one is electron emission. electron emission Electron emission. What is electron emission? And we also discuss so the work function, electron emission and work function. So after discussing these two topics, we'll uh, discuss an actual important topic, that is photoelectric effect. Already you have learned it in the chemistry in the uh, first year. Okay, first we have to know what is emission. Electron emission. So we know that uh, metals contains number of free electrons. Number of free electrons. Nothing but they are very every material is made of atoms, and center of the atom, the is positive charge, and around the positive charge electron revolves in different orbit. But in case of metals, electrons are loosely attached to the parent nucleus. Okay, so they can, even at room temperatures only, they can free from the atom and they roam on the surface of the metal. Okay, so if you take a metal surface, and these are the positive ions, nothing but nucleus, and at room temperatures only these electrons move on the surface of the metal, but they are free from the metal surface, they are free from atom, but they are at room temperatures they can become free from the atom but cannot become free from the metal surface. Okay, so once again coming to this topic, metals contain number of free electrons. Okay, so and these are responsible for electrical conduction. So when an electron, if an electron so attempts to come out from the come out from the metal surface, from the metal so what happens, if this electron is trying to come out from the metal surface, when an electron come out from the metal surface, there are eight I will represent one more electron here. So when an electron is coming out from the nucleus somehow, so the metal become positively charged body, and electron is negatively charged body. There exists a attractive force, large attractive force. Okay, because of this attractive force, so this electron which is trying to come out from the nucleus, okay, come out from the nucleus, will be pulled back to the metal surface because there exists a large attractive force. Because of this attractive force, it comes to its actual surface. Okay, so so electron by themselves not come out from the metal surface. Okay, we need to apply some energy externally, we need to provide energy externally. Okay, so that energy, the minimum, so work function, here I am going to discuss about what is the work function. So and then I'll come to electron emission. So work function is that minimum energy, the minimum energy required to, remove an electron from the metal surface, metal surface is known as work function, okay. So electron, once again I am repeating, electrons by themselves cannot come out from the metal surface. So when you provide an external energy, so if you provide energy externally, okay, so these electrons absorb that energy, and that energy should be more than this attractive energy, then only the electron can come out from the metal surface. That energy is called the work function. Whatever the energy required to remove electron from the metal surface is said to be the work function of that metal. Okay, for that metal, so it is generally, the work function is denoted by work function. Work function is different for different metals. Why? Because the attractive force between the electron and nucleus is different for different metals, so the work function is also different. Okay, atomic structure of different metal is different, means atomic arrangement of different atoms in different metals are different, so work function is also different for different metals. So work function is denoted by pi naught or w naught. Okay, so generally it is measured. So how it in measured? So it is measured, work function is measured in electron volts. E dot B electron volts. This is it is a unit of electric energy. So this is electron volt. Okay, so measured in electron volt. So what is 1 electron volt? What is an electron volt? Okay, so here electron volt is nothing but 1 electron volt generally in joules. 1 electron volt is equals to 1.6 into 10 power of minus 19 joules. Okay, 1 electron volt of electric energy is equals to 1.6 into 10 power of minus 19 joules of mechanical energy. Okay, this is a energy equivalent of 1 electron volt in joules. Okay, so 1 electron nothing but when you apply 1 volt of potential difference to 1 electron, then the energy associated with it is with the electron is said to be 1 electron volt. Okay, this is about the work function. Okay, and electron emission. So I will show some slide here. Once again, see the definition. So one just a minute. Right. So look at the definition once again. So first, so work function, the minimum energy required for an electron to escape out or remove an electron from the metal surface is work function. So already discussed, denoted by pi naught or W naught. So measured in electron volts. What is 1 electron volt? The energy gained by electron when you apply 1 volt of potential difference. Okay, then the energy associated with it is said to be 1 electron volt, and it is equals to 1.6 into 10 power minus 19 joules. Okay, so next, now we have to discuss what is electron emission. Electron emission is this process of emitting electron from the metal surface is known as electron emission. So electron emission is of 3 types: thermionic emission, field emission, photoelectric emission. Okay, you can remove electron from the metal in by applying 3 different energies. So based on that, there are three types of emission. First one is thermionic emission. By heating the metal surface, electrons are emitted from it. Okay, so if you this is a metal, so already sorry 1 minute. Okay, sound disturbing. Right. So if you have a metal, okay, so this is I'm representing only one positive ion. This is an electron. Okay, if you provide heat energy, okay, if you provide heat energy, so so this electron can absorb that heat energy and it can come out from the metal surface. So this is known as thermionic emission. Okay, and the emitted electrons are known as thermoelectrons. Okay, so by applying heat energy also you can remove electron from the metal surface, and based on that heat energy we are calling it thermal energy. This, since we are providing thermal energy, nothing but heat energy, and the emission is known as thermionic emission, and the electrons which are emitted from the metal surface are known as thermoelectrons. And next one is field emission. If you provide a very strong electric field, okay, if you provide, this is a metal, this is a metal, if you provide if you place metal surface within the electric field, this is let it be plus and minus, there exists an electric field. If you place a metal uh, in the electric field, so when you apply very strong electric field, let it be the strong electric field, when you apply strong electric field, electrons attracted towards the positively charged plate. These are the positive plate, this is a positive plate, this is a negative plate. When electrons are if you apply a very strong electric field, this electric field can pull electrons from the metal surface, and so this process is known as field emission. So electrons are emitted by applying very strong electric field. That is why it is known as field emission. Okay. And next one is photoelectric emissions. In the first process we apply thermal energy, in the second process we apply electric field, in the third emission we are applying light energy. When a light of suitable frequency incident on the metal surface also, so we can, in that process also we can, electrons can also come out from the metal surface, and the emitted electrons are known as photoelectrons. The electrons emitted due to light energy. When light incident on the metal surface, electrons are emitted from it. So these are known as photoelectron. This is light energy, and the incoming energy is light energy. Outgoing particle is electron. Okay. So work function is different for different materials. Okay. So work function is lowest for cesium and highest for platinum. Okay. So here, so cesium, the work function is 2.14 electron volts. If you apply 2.14 volts, 14 electron volts of energy, then you can easily remove electron from the metal surface. Okay. And but if you want to remove electrons from the platinum, if you want to apply large uh, electric energy, okay, you need to apply 5.65 electron volts of energy, then only you can remove electron from the metal surface. And these are the work functions of different materials, and it is work function is a function of metal. Okay, different materials, the work function is different. Okay, so and this is about the introduction class.